Hi again. This is question number 48 from section 6.3. Well, I should say it's the one like that section problem. And anyway, it's f of x equals 3 raised to the x over 2 power plus 1. So we need to graph this using transformations. Now, unfortunately, I gave you this one not really meaning to, but the problem actually has a horizontal stretch actually on this one. And we didn't really talk about horizontal stretches and horizontal compressions when we were doing the transformations back in, I believe, 3.5. And but I'm going to show you how to do it, but don't worry so much about this particular problem. And the only thing you really should have trouble with, is the x over 2 part of it. Now, went in and graphed y equals 3 to the x. That's our normal exponential function. 3 to the 0 is 1, 3 to the 1 is 3, 3 to the second is up here at 9, 3 to the negative 1 would be at 1/3. And so you plot those points, and that's kind of what 3 to the x looks like. And but what this will do, the x over 2, it will horizontally stretch out. When you divide the x by 2 in a transformation like that, it basically pulls every point that's on the y-axis twice to what it was. So this point right here is 1 unit from it. And so now it will be 2 units from it. This one right here at -1, 1/3, will be right here at -2, 1/3. So in essence, what it's doing, it's taking the graph and it is pulling it away from the y-axis by a factor of 2. So what I've done just now is the graph of y equals 3 to the x over 2. So it just takes it and stretches out. So you find any point that you have, and you double the distance between that point and the y-axis, and that creates another point. And so that's what I did. So this one's twice as far. So this one right here up at 9 would be 2 units from it. So that would be 4 units away at the same point. So it would be 4, 9. So the next thing we do is we add the 1. So you take this graph that I have dotted here, that dashed line, and then move it up 1 unit. And that would be your final result. So this point right here at -2, 1/3, okay, would be at -2, 1 1/3. Okay, and since there's a horizontal asymptote, we'll put a horizontal asymptote right underneath it, because this creates the horizontal asymptote of 1. And so every point that I have here, move it up 1 unit. So what happens is this one is it right there. So that is the function f of x. So this thing has 2 transformations, a horizontal stretch, and then that means it just pulls it away from the y-axis by a factor of 2, and then the 1 will just move that result up 1 unit. But like I said, we didn't talk so much about the horizontal and the horizontal stretches and horizontal compressions. So if you can't figure out 48 before you look at this video clip, that's fine. That's fine. Just try the best you can, but that is a horizontal stretch. And if this was 2 times x instead of x over 2, that would be a horizontal compression. It actually brings it in by a factor of 2. So, but anyway, that's it. That's number 48.